All right, so we just got a couple more pieces left, just one more think and one more meaningful notes. So I know it's the very beginning of the video, but I want you to take a minute together to do this think. So I want you to read it. Let's take 5 minutes. So let's pause the video for 5 minutes, read it, fill in the table, and then choose which of the answer options could represent the relationship. So it could be more than one answer. Pause the video for 5 minutes. All right, so you had some time to think about it. So let's go through together what is going on. So it says the table shows a relationship between the base length B and the area A of some parallelograms. All the parallelograms have the same height. Base length is measured in inches and the area is measured in square inches. Complete the table. So first of all, if parallelograms is a new word for you, it's actually not super important for our work, but parallelograms just mean that opposite sides are parallel. It has 4 sides. So it gives us a table and it kind of gives us a starting point of the base length and then what the area would be. And you want to be able to finish out the table, you want to be able to figure out the relationship between the base column and the area column. And so I want to look at the very first row, and our base is 1, our area is 3. And I kind of formulate a couple hypotheses. So one is that we could be adding 2. So to get from 1 to 3, I could add 2. Another hypothesis I have is that you could multiply by 3. So you can get from 1 to 3 by multiplying by 3. Those are really the only 2 that I have right now. So let's see if either of them work out as we go down. So the next line, let's test my plus 2 theory. So I do 2 plus 2. Is that 6? It's not. So that theory is automatically out. If any of the rows don't work, then your theory can't be right. So my second hypothesis was to multiply by 3. Well, 2 times 3 is 6, so that worked out. Now let's check the last line that they give us in its entirety, and that's 3 and 9. Well, 3 times 3 is 9, so that works out for that theory as well. So I'm pretty confident then to get from the base column to the area column, all they're doing is multiplying by 3. So to finish out this table, I'm going to fill in the missing pieces by just multiplying by 3. So the row that has 4.5, we have 4.5 times 3, and that's 13.5. Then the next one is 11 over 2. Well, 11 over 2, I can type that in my calculator using the fraction button, or I can figure out that as a decimal, it is 5.5. So 5.5 or 11 over 2 times 3 is 16.5. And the next 2 rows kind of have us working backwards. Well, if we multiply by 3 to get from the first column to the second, to undo that, we know the opposite of multiplication is division. So I could do 36 divided by 3 to get 12. And 46.5 divided by 3 to give 15.5. So now that our table is complete, it says to decide whether each equation could represent the relationship between B and A. Well, we already know the relationship because we used that relationship to fill it out. We said we multiply by 3 to get from B to A. So I take B, I multiply by 3, and I get to A. If I look at my equations, I can see, well, option D has me multiplying by 3 to get to A. But remember I said it could be more than 1, and we did that actually. In our last 2 rows, we didn't multiply B by 3 to get A. We took A and we divided by 3. And so another option could be that we take the area and we divide by 3, which is option B. So we have 2 kind of options that describe this relationship pretty adequately. It's important to talk about like when each of these would be useful, like why have more than one. And so we're going to kind of take a look at that right now in our meaningful notes. So we kind of just talked about like when it is important, or when it's an option that you have more than one equation, when each would be best. So there's sometimes more than one equation that describes a relationship. And we've been talking about that for about a week, that you can have something different than your neighbor and still have the meaning correct. And so sometimes there's more than one equation that describes a relationship. In that case, we want to be really careful about which one we choose. So we want to have the unknown, or the variable we are trying to find. So we want to have the unknown, or the variable we're trying to find, by itself. So something like, in the last one, it would say A equals. And that's because if that's the thing we're trying to find, everything that we know is going to be on the other side of the equation. So we can plug in all the stuff we know and find out what we need to find. So in our example, we have, I'm going to kind of make a new box right here. So in our example, if we know the base, we want the A equals equation. But if we know the area, we want the B equals equation. Okay, so it can depend based on what we know or don't know. So if we know one thing, we can kind of change as we go. So there are practice problems in this packet right below where we are working. I want you to take the rest of the time and work on those. When I get back, I will be checking your notes to make sure you have these notes, as well as your practice problems. That'll be considered your homework if you don't finish it in class today. But you should have enough time to work on those before we get out of class. Looking forward to seeing you all tomorrow.